Alright, so moving on here to letter D, here we have the log of 3 and square root of 27 there. So here we're given logarithmic form. Now we change it into exponential form. So when we're doing that, our 3 here is our base, square root of 27 is our number, and we'll let y be the exponent. So we have 3 to the power of y is equal to the square root of 27. Alright, so from there what we can do is, let's rewrite or if we can rewrite both of them as the same base, or what we'll do is, first of all, we'll get rid of this, or we'll rewrite this square root. So we have 3 to the power of y is equal to 27. If you guys remember what the square root is as a fraction, as an exponent, that is 27 to the 1/2. That means the exact same thing as the square root there. And then from there we're going to rewrite 27 as having a base of 3. So we have 3y is equal to, if you guys remember what 27 is, that is 3 cubed to the 1/2. I'm going to keep writing up here. Then we're going to use our exponent rules. So we have 3 times 1/2. So be 3y is equal to 3 to the 3 over 2, Now that we have the same base, now we can use our exponent rules where our exponents must be equal. So y must be equal to 3 over 2. Alright. So that there is just, oh wow, okay. That there is solving. So change it from logarithmic form to exponential form, and then just solve, and then if you need to, if your variable is in that exponent, then you need to find common bases, and if not, we're going to have to go with our trial and error or graphing again. So quite wonderful there. Alright. So number 3 here. Sorry for all that scribbling, I'm just going to delete all that. Oh boy. Okay. So number 3 says the intensity of sound is measured in decibels. The level of sound, L, in decibels is given by this wonderful logarithmic form. So we have 10 log of, this is I, divide that by I naught. That little 0, or that little, that little 0 or O means, usually people pronounce it as naught, but you can just say I and I-O if you like. And so where I is the intensity of sound, and I naught, or I0, is the faintest sound detectable to humans. So the sound level inside a particular car is 39 decibels when it's idling and 80 decibels at full throttle. So they want to know how many more times how many times more intense is the sound at full throttle when compared to when it's idling. So this one here we're gonna have to look at two different two different equations. So we have when we're idling, and L when we're at full throttle. So we have to find those two, and then what we're going to do is we're going to compare them by dividing them. So find out how many times greater one is than the other. So in idle, we're going to be using our logarithmic form here. So we have L is equal to 10 log of I divided that by I naught. Here in this question, we are given that L, when it's idling, is at 39. And we're not really given anything else, so we just got to rewrite it as it is. We have 39 is equal to 10 log of I divided that by I naught. Just scroll on down there. I'm not sure why my pen is doing that today. Alright. So then from there, what we can do is, let's get this log I divided by I naught. Let's get that by itself. So let's get rid of this 10. And how are you going to get rid of that? So these two here, I guess we could say is that they're multiplying together there. So if they're multiplying 10 and log of I divided that by I naught, so then let's divide. So divide each side by 10. And what we're left with is 3.9 is equal to the log of I divided that by I naught. Then from here, this looks a little bit more like what we've been doing in the previous question, so let's solve for it. So let's write this into exponential form. So if you guys remember your log, you have your base. So our base here is equal to 10. It's not written there. And this is our number. And this here is our exponent. So we'll have 10 to the 3.9 is equal to I divided by I naught. Okay? And then because we're solving for, we want to know what I is, so the intensity of the sound when it's idling, we're going to solve for I. So we need to get rid of this I naught in the bottom, because we don't know what the intensity or the faintest sound detectable to humans is. So what we'll do is we'll get I naught onto the other side, and you'll kind of see that this works out really nicely. So to do that, we will multiply since it's dividing here. So we have 10 to the power of 3.9 times I naught, and that is equal to I. And if we want to give that a little, we can maybe say I to the, let's say I to the I, just that we're saying that that is the intensity of the sound when we're in idle. So that'll be what little I there means. Okay? So now we're going to do that exact same thing to full throttle. So let's go scroll back up here, ladies. Okay, so now we need to find what the intensity is when we're at full throttle. Alright, so we have we're going to use that exact same equation, or same function. So we have L is equal to 10 log of I over I naught. And that's why I gave that other one previously at the bottom there. That's why I kind of labeled it I to the little I. So this one we could say IF, so that'll be I at full throttle. And then looking at this question, what do we know? The only thing that we're really given for this section, or for this part of the question, is that we know that it is at 80 decibels when we're at full throttle. So L is equal to 80, and that is equal to 10 log of the intensity of full throttle divided by I naught. Okay, so similar to what we did to the last question, we're going to solve for the log of I divided by I naught. So we'll divide here by 10. So we have 8 is equal to the log of the intensity of full throttle divided by I naught, or that's the faintest sound a human can hear. Oh goodness. Oh goodness. Alright. Then from there, once again, we will keep on solving just like we did before. So we're going to write this into exponential form, because we don't like logarithmic form. So we're going to put this into exponential form. So here our base is 10, our exponent is 8, and it is equal to that number, which is IF divided by I naught. Alright. So in the last step, we want to get this intensity at full throttle by itself. So we're going to get rid of this, or we're going to move that I naught to the other side. So we'll multiply. So what we're left with is 10 to the power of 8 times it by I naught is equal to IF. Okay. So we've found, or we're attempting to find what the, I guess what our intensities are at idle and full throttle. And so we're not given anything else in the equation, so, or in the question, so this is as far as we can go for finding out those intensities. So now what we're going to do is we're going to compare them. And I'm just going to quickly erase this, so hope you guys have that written down. If not, pause it. I'm just going to write this, erase this so we have a little bit more room here. Alright, so now what we're going to do is we're going to compare here. So we're going to compare our intensity at full throttle, divide that by our intensity when we're in idle. So that's how we're going to compare there. Okay, so we have IF, divide that by the intensity of when we're in idle. And so we're gonna have this as, so we're gonna write this as equal. So what was IF equal to? And if you guys remember there, IF for your intensity at full throttle was equal to 10 to the power of 8 times it by I naught. And your intensity in idle is equal to 10 to the power of 3.9 times I naught. And then from here we just solve. So we have IF divided by II. That is equal to, so from here we just simplify. So we can cancel those I naughts. So these two are the exact same value. So say we had x over x, those two would cancel out. So similar to this, these are both the exact same values, so we can cancel them out. So what we're left with is 10 to the power of 8 divided by 10 to the power of 3.9. If you guys put that into your calculators, or if you guys want to use your, I guess if you guys know your exponent rules, when you're dividing, you'd have, as long as they have the same base, we'd go 10 to the 8, and with division we subtract 3.9. Sorry about that. Alright. And then from there we could say that IF over II is equal to 10 to the power of 4.1. Then if you guys want to, you guys could leave it like this, or we could further simplify. We have I to the, or IF divided by II is equal to, if you put that into your calculator, you guys should find that we have 12,589.25. And so that right there basically is what we're saying, that the sound at full throttle is about 12,589 times as intense as a sound at idle, okay? And so this is a word problem, so let's write that as a sentence. So the sound at full throttle is about, and make sure you say about, it's not exactly, and we'll just round it to the nearest whole number, so it is about 12,589 times as intense as the sound at idle. Okay. So for this one was a little bit tricky there, but essentially what we did here, so first of all we found out what our intensities were for when we were in idle, and then when we were in full throttle, and then we compared them, so we divided them. How many more times intense is full throttle than when we're in idle? If we were to do, say if we did, if I can find my little cursor there, if we did II over IF, this one would give us a really small decimal, so this one would basically be asking how many times less intense is the intensity at idle compared to the intensity at full throttle. So we wouldn't want to do that. So if you guys even did this, then you guys come with some random decimal there, and you would notice that doesn't really make sense. You know, you can't have point, if something's supposed to be greater, it shouldn't have a small decimal. So there's even a nice little clue there. So we got a nice big number, which would make sense because we were compared from 39 to 80. So if we were comparing the big one, it should have a larger number, right? Okay, and then from there we just did our sentence just to kind of finish off that problem. Okay, so we're going to switch over to video number 3 to finish off that last one. It's just a nice little graphing one, so it'll be alright. Okay, so switch over to number 3 right now.